In this video, I'll show you how to get started with Sensor Toolkit. After importing, find it in Assets, Sensor Toolkit. There are three kinds of sensors. Ray sensors detect along a line, range sensors detect within a radius, and trigger sensors detect using trigger colliders. There are 3D and 2D versions of each sensor. In my demo scene, there is a sheriff and a thief. I'll make the sheriff detect the thief when it's nearby and chase and catch him. The sheriff and the thief already have rigid bodies attached and capsule colliders attached on child game objects. The sensors use the collision detection system, so anything you want to detect has to have a collider. Either the range sensor or the trigger sensor would be appropriate for this. I'm going to use the range sensor because it's a bit easier to configure. I'll show you the trigger sensor in another video. I'll select the sheriff and add a range sensor component. I'll increase the sensor range. I'll add the sheriff to the ignore list so it doesn't detect himself. Enable the tag filter so the sensor only detects objects with specific tags. I'll set detect on layers to character. This is a physics layer I've already set up for this, and I've set the sheriff and the thief both to this layer. I'll set the detection mode to rigid bodies. This is really useful when you have rigid bodies with colliders on child game objects, which I have here. Let me demonstrate. I click test and the sensor detects the thief. I change this to colliders and click test, and it's detected two different game objects. This is the game object which has the actual capsule collider component, but not the root game object with the rigid body. The other one it detected was the one under the sheriff. I'll set back to rigid bodies. I'll leave the sensor update mode as fixed interval with a check interval of 1 second. This means the sensor will automatically update every 1 second. You can set it to manual if you want to update the sensor yourself with either a script or a playmaker action. I'll come back to line of sight testing. You can assign any event handlers here for when something's detected or when a detection is lost. These two parameters can be left as defaults. The sensor avoids memory allocations by using a fixed size array. A new array will be created if it's not large enough, double the size of the previous. Now the sensor's set up, I'll create a script that uses it. I'll create a new script. I'll call it Sheriff Chase Thief. First, we need to use the sensor toolkit namespace. On update, I'll check the sensor to see if it detects anything. If it does, I'll chase it. If it doesn't, I'll go idle. While chasing, I'll turn to face the target. And I'll move towards it. Let's say if we get within half a meter of the target, then the sheriff has caught it. So we'll remove it from the game. Okay, let's give that a try. Just have to allocate the animator and the sensor. And there we go. Now let's enable line of sight testing, so the sheriff won't be able to see the thief if it's hiding behind this plant. Okay, so I'll just check here, and I'll set the layer blocking line of sight should be environment. That's another physics layer I've already created, and the plant has already been assigned to it. Set the number of rays to test with to 5, and the minimum visibility is 0.5, which means to be detected, at least 50% of the rays need to be unobstructed. So when line of sight is enabled, it means that the any object detected by the sensor's range, so is within range of the sensor, must additionally pass this line of sight test to be detected. So I'll click test, and there's two lists now. There's this objects detected list, which is empty. So this will be any objects that were detected and passed the line of sight test. And there's the not detected list, which the thief is currently in. So this is for objects that were within range but failed the line of sight test. Here it had a visibility score of 0%, and we can click this checkbox to get a better view of what actually happened. So we can see that all 5 rays originated from the sheriff's feet and were obstructed by the plant and didn't reach the thief. One problem I see here is that the rays are all originating from the feet, but I'd rather the rays originate from the sheriff's head or near his eyes. To do that, we'll need to put the sensor on a game object that's a child of the sheriff. So I'll do that. Let's create a new game object and call it eyes, and I want to position that just somewhere on the head. Then I'll move the range sensor to there. Okay, now if we click test, all the rays are originating from the head. Alright, so we'll need to reassign the eyes here. So currently these test points that the line of sight is testing against are randomly generated. If we want to have specific test points, for example, if I want it to test against each of his hands and the feet and the head, then there's a way to do that. We can go to the thief and add a component called LOS targets, and within here we want to add the list of bones that we want to check against. Alright, so just get the head out, put that in there. This shoulder left joint with the hand, shoulder right joint, the right hand. Okay. So the left foot. And the right foot. Okay. Now if we try it, here we can see the rays are pointing at the feet, the hands, and the head. Alright. Let me move this plant slightly out of the way. Try again. Okay, in this case all of the rays have hit it. So maybe I can move it slightly in the middle. There you go. 40% visibility. Some of the rays were hit on the plant, and a couple of them actually reached it.